Hi there. This video I'm going to show you how to think about absolute value and distance as one and the same. So let's start with absolute value, what it is and what it does. Um, we're going to take the absolute value of c, and c is a number, and this is defined as what's called a piecewise function. If what we put in that c value to the absolute value is positive or even 0. All right, so when the c that we put in is either positive or 0, the absolute value of c is, well, the same thing that we put in. Okay, so if we put in 9, for example, the absolute value of 9, since 9 is positive, it equals 9. The absolute value of 0 equals 0. Absolute value of 883, 883. Okay, but it does something to values that are less than 0 or negative. So when those negative values go into the absolute value bars, they come out as the opposite of what they came in as. Now, don't let that negative sign fool you, right? That whole becomes positive because we're taking the opposite of an already negative number, and the opposite of an already negative number is positive. So even though that looks like it's negative, it's not. Okay, so here are a couple basic examples. We say the absolute value of 43.6 is 43.6. Absolute value of 0 is 0. Again, if something is positive and it goes in, it comes out as the same. If something is 0 going into the absolute value, it comes in as out as 0. Okay, the only changes we see is when we get the absolute value of a negative value, like negative 6. So by definition, what the absolute value does is, since negative 6c is going in, then what we do is we take the opposite of that. So it's the opposite of that already negative 6, right? And that's how we get positive 6. Okay. Now, that said, we can use absolute value to think about distance. So let's take a look at a number line, and that's a nice little number line there. And let's put 2 points on this number line. Doesn't matter which ones. We'll take, say, negative 6 and 3. Okay, so what's the distance between those 2 points? Now we're talking about distance between 2 points on a line, okay, not on a Cartesian plane where we might have to use, in all likelihood, the distance formula. But we're talking about distance between 2 points on a line. And one way to find distance between these 2 points is to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like the distance is 9, and I got that in a very elementary way, simply by counting. But obviously counting is not always going to work. And of course this is an algebraic lesson, so let's think about how we can think about how to express that algebraically. What we're going to do is we're going to be using the absolute value. So the basic idea is this: to express the distance between 2 points, a and b, two numbers rather, is just b minus a is the distance, and it doesn't matter really the order, because we're going to take the absolute value anyway. Points on a line. So going back to that example we just talked about, here's negative 6 over here, here's 3. Well, the distance is negative 6 minus 3, absolute value of, and to evaluate that, negative 6 minus 3 is negative 9. Right? We work within the absolute value first, and then after all is simplified, we take the absolute value of that, which is 9. Okay, same 9 we expected. What, comma, if, comma, we went the other way. What if we left it as 3 minus negative 6? Right? And again, the distance between 2 points, this hopefully will convince you that it doesn't matter which way you express the order. 3 minus negative 6 is 9, which also is 9. Okay? So if we can express distance using an absolute value, then we can certainly interject a variable. So what if I gave you this problem? The distance between a number, we'll call that number x, and I'll put in parentheses, and let's say negative 2 is 6. Find, quote unquote, the number. And I'm putting that in quotations for a reason. So let's bring back that line so we can get a nice visual. So if we're going to call that number, we're looking for x. Okay, so here's negative 2. And so we're trying to find the quote-unquote 1 number whose distance from -2 is 6. So I'm going to move 6 direct, and I jumps 1, 2, 3, 4, 5, 6. Bam. Okay, 4 is one possible solution. But because we're on the number line, I can also move to the left 6 units. 1, 2, 3, 4. Oops. And arrive at 1, 2, 3, 4, 5, 6. Bam. Okay. So it's not really a number, it's two numbers. Okay, it's not really the number, it's the numbers. Okay, but there's got to be an algebraic way to do this, and here it is, right? So the distance between x and -2. Now that, recall, I can express as this. The absolute value of their differences. X and -2, right? So the absolute value of their difference is the distance. And we want that to equal 6, right? So here's the thing, right? One of two things can happen. I'm just going to clean that up first. Minus -2 is +2. And because of the nature of the absolute values and the piecewise way in which we define it, two things can happen. Either x plus 2 can be 6, right? Or what if x plus 2 as its entirety were -6, right? So what if this little chunk in here turned out to be -6? Well, we take the absolute value of it and it would turn it back into 6 anyway. Okay, so we have two possible solutions. One where the absolute value of whatever we're taking is 6. The other where the absolute value of this x plus 2 is -6. So if I solve here, I get 4. And if I solve this, I get -8. Okay, and that's, of course, an OR statement. All right, so that's how we solve algebraically distance problems or absolute value problems. We split it up. And we can also think about it on the number line counting. Okay, and one is no better than the other. Usually algebra allows us to do more things, particularly more complicated problems. Thanks for listening. Keep it real.